Bismillahirrahmanirrahim. In this lecture, I am solving problem 6.33 from the book Fundamental of Thermodynamics by BORGNAKKE. So the statement of the problem is helium is throttled from 1.2 megapascal and 20 degrees centigrade. So in given data, helium gas is used in process is throttling. And we know that in throttling process we assume adiabatic process Q is equal to 0 and H1 is equal to H2 and no work is involved in throttling process. From 1.2 initial pressure is 1.2 megapascal and initial temperature is 20 degrees centigrade to a pressure of and 1.2 megapascal is equal to 1.2 multiplied by 1000 kilopascal. So P1 is equal to 1200 kilopascal. 1200 kilopascal to a pressure of 100 kilopascal means P2 is equal to 100 kilopascal. The diameter of the exit pipe is so much larger than that of the inlet pipe that the inlet and exit velocity are equal. It means that V of inlet is equal to V of exit. In some book this is denoted by C and in this book this is denoted by V. So both are correct. Find the exit temperature of the helium T2 for helium and the ratio of the pipe diameter D2 divided by D1. These are the required values. So we start solution. There are some assumption before solution. We know that process is throttling process. So in throttling process, we assume that this is adiabatic process. Adiabatic process mean that no heat loss are gained by the system. So Q is equal to 0. Q is equal to 0. And this is also isentropic process. H1 is equal to H2. And no work involved. No work involved in this system. And potential energy change in potential energy is negligible. It means that Z1 is equal to Z2. Now in solution the steady state equation is Q minus W plus M dot H1 plus V inlet square divided by 2 plus GZ1 is equal to M dot H2 plus V exit square divided by 2 plus GZ2. So here the process is adiabatic, so Q is equal to 0 and no work involved, so W will be also equal to 0. So M dot H1 plus V inlet square divided by 2 plus GZ1 is equal to M dot into H2 plus V exit square divided by 2 plus GZ2. So both sides divided by M dot. So M dot will be cancelled. So H1 is H1 plus Vi square divided by 2 plus GZ1 is equal to H2 plus V exit square divided by 2 plus GZ2. So GZ1 will be cancelled with GZ2 because Z1 is equal to Z2 and V1 is equal to V2, so it will be cancelled. So H1 is equal to H2. H1 is equal to CPT1 and H2 is equal to CPT2. Both sides divided by CP, so this implies that T1 is equal to T2. And we know that T1 is equal to 20 degrees centigrade. So T2 exit temperature is also equal to 20 degrees centigrade. So this is the value of exit temperature. So exit temperature and inlet temperature are same, 20 degrees centigrade. Now from the continuity equation, m dot is equal to rho 1 a inlet, or we can write a inlet or a1, both are same, a1 and v inlet square is equal to rho 2 a2 or a exit into v exit square. As v1 is equal to v2, as v1 is equal to v2, so both are divided by v1 v, so rho 1 a1 is equal to rho 2 a2, or we can write this as a2 divided by a1 is equal to a2 divided by a1 is equal to rho 1 divided by rho 2. Cross sectional area is equal to pi by 4 d square. So pi by 4 d2 square divided by pi by 4 d1 square is equal to, from ideally this equation we know that PV is equal to MRT, or we can write this P is equal to M by V RT, and mass divided by volume is equal to rho density, rho RT. So from this equation I can write this rho is equal to P divided by RT. So here I can write rho 1 as P divided by RT divided by, this is P1, this is RT1, but T1 is equal to T2, so I can write this as T, and P2 divided by RT2. So R will be cancelled with R and T will be cancelled. T1 will be cancelled with T2 because both are same, 20 degrees centigrade. So and pi by 4 will be cancelled with pi by 4. So D2 square, D2 divided by D1 whole square is equal to P1 divided by P2. Are taking under root on both sides, so I can write this as D2 divided by D1 is equal to under the root P1 divided by P2. So d2 divided by d1 is equal to under the root P1 is equal to 1200 kilopascal and P2 is equal to 100 kilopascal. So kilopascal will be cancelled with kilopascal, 20 will be cancelled with 20. So d2 divided by d1 is equal to under the root 12 and d2 divided by d1 is equal to 3.464, and this is the ratio of exit and inlet diameters, and exit temperature is 20 degrees centigrade. So this is the end of the problem, and for more problems please like and subscribe my YouTube channel and share with your friends. Thank you.